Good morning, students. Today we are going to start a very interesting topic, that is chemical bonding and molecular structures. So we are going to discuss how atoms form molecules and what kind of interaction is there in between. So we are going to cover in this topic. So here you can see there are two atoms with a positive nuclei in the center and surrounded by electronic cloud. They always tend to form bond with other atom. So they attract other atom and form a molecule. So here you can see that atom 1 and atom 2 are attracted toward each other. Their nucleus are attracting because of the electronic cloud and they form a molecule. Okay. Then they are forming a bond which is not visible to us, but we represent like atom 1 is forming a bond with atom 2 with this kind of line, but that is not the real case. We cannot see such kind of structure in reality. Here the electronic clouds overmerge and they form a molecule. So this bond, what is a bond? Which is keeping these atoms together. So it is a force of attraction between the atom. Here you can see that it is clearly written that bond is the force of attraction between the atoms. Now, this bond formation and this energy which keeps them together, this force of attraction which keeps them together is very much essential. Okay. So, and it results in so many compounds which are surrounded in our nature. So here you can say that very first molecule is the water. Okay. Here you can see that water is the molecule. We can see that which consists of a covalent bonds, sodium chloride, salt, table salt, carbon dioxide that we exhale in the atmosphere, methane, that is one kind of natural gas is there. Okay. And this is ammonium, which is NH3 is there. Hydrochloric acid, you know this thing. Nitric acid, acetic acid, which is vinegar, and calcium carbonate, sucrose, sulfuric acid, glycerol. These are the chemical compounds, and various other chemical compounds are there which are surrounded in our nature. So these are the chemical compounds which are resulted due to bond formation between the atoms. So the bond formation is very much essential because even our body part, various chemicals inside our body, various organic and inorganic materials, compounds which are present inside our body are resulted due to the bond formation. Now we are going more about this. What is chemical bonding? As we already discussed, it is an attractive force. Let me change this to pen. Okay, the attractive force which holds together the atoms or group of atoms in a chemical synthesis are known as chemical bond. But these bondings, whatever bond formation is happening, is not possible with every condition. There are some specific combination of atoms which results in the bond formation and that result in a molecule with specific shapes. Okay, so there are specific combination is needed for a bond formation. Is needed for the bond formation. Okay, and this bond formation leads to the molecules with a specific shape. Now, there are so many theories which are developed regarding the molecule formation, bond formation. So the very first theory was the Coastal-Lewis approach. It was a time in 1962 when the classical approach of atom was there. Due to the Bohr atom, you can see that when Bohr discovered the structure of atom, or he described the structure of atom, at that time this approach came. Then valency shell electron pair repulsion theory. This is the second theory. Then valency bond theory. Then molecular orbital theory. These theory we are going to cover later. But today we are going to discuss more about the Coastal-Lewis approach. Okay, and this kind of approach, how it defines the molecular formation. So Coastal-Lewis approach tells that the atom consists of a positive nuclei. This is the nucleus. We know that, and it is surrounded by electronic cloud, which contains of K cell, L cell, M cell, and so if you know, it is the L cell. This kind of cell is there. So he told that according to him, this positive nucleus, along with the penultimate means the previous, this completely filled cell, he called it as a kernel. And the last valency cell, which is last cell of the atom, is called the valency cell. And according to the theory, this cell, the valency cell, takes part in the bond formation. So this is valency cell is interacted with the other atom and resulted in the bond formation. So here you can see that the Coastal-Lewis approach described the concept of kernel and valency cell. In the formation of a molecule, only outer cell, that is a valency cell, electrons take part in a chemical combination and they are known as a valency cell electrons or valency cell. Okay. Now, what are the Lewis symbols? We know that if the dot structure, like hydrogen you see, how we represent the hydrogen. Hydrogen we represent with single dot electron. Helium we represent with the 2 electrons. Lithium we can represent 3 electrons. Then beryllium we represent with 4 electrons. Then boron we represent with the 3 electron. So these representation with electrons, you can see, these are the Lewis dot structure. And these dot structure, whatever things are there, they represent the outer number of cell. Okay. So hydrogen is having only 1, helium is having 2, beryllium is going to have, like lithium is going to have 1, beryllium is going to have 2. Okay. And boron is going to have 3. So this dotted structure shows the valency number of cells. In case of beryllium, it will be the 2. In case of lithium, it will be the 1. Okay. So this represents the valency cell electrons. Okay. So Lewis dot structure shows the Lewis symbols. These are the number of electrons, and this valency cell electrons shows that its beryllium is having 2 electrons in the outer valence, lithium is having 1, and boron is having 3. Helium is having 2, and hydrogen is having 1. So these dotted structures show the number of valency electrons outside, out in the valency cell. Okay. Now, this Coastal-Lewis approach is also known as the electronic theory of chemical bonding, because the valency cell, the concept of valency cell they have given, and these valency cells take part in the chemical bonding. So bonds which are formed is the bond which formed because of the valency electron, and these valency electrons are in the valency cell. Okay. So this concept, whatever they were given by the Coastal-Lewis, they are responsible for the electronic theory of chemical bonding. Okay. So that's why this Coastal-Lewis approach is also known as electronic theory of chemical bonding. Now, this whole theory depends on the octet rule. What is an octet? Octet means number 8. So atoms want to attain an octet. Okay. So this octet is, if anything is less than 8, so all the atoms try to gain complete 8 number and occupy it as a stable configuration. So if anything is like suppose 7, they want to get 1 electron. 8, if they have 1 electron in the outermost cell, they will donate it so that they can have octet in the innermost cell. Then how we can achieve this octet? How the atoms can achieve octet? They can achieve octet by the transfer of electrons, which we are going to study as a ionic bonding. We are going to study in detail in the upcoming slide. Sharing of electrons, which we can say that as a covalent bonding. Okay, so atoms can achieve octet by transfer of valency electrons from one atom to another. Suppose these atoms are having 1 electron or 2 electron more than their complete octet, or they are having an outer valency cell 2 electron extra. So they will donate it. So that is transfer of valence electron. Suppose transfer of valence electron to another atom, and so they have in the outermost cell complete 8 electrons. Sharing of electron is there. Suppose they have 1 electron and they will gain 1 electron and then will complete the octet. So this kind of thing is there. Covalent bonding we will describe more in the structure later. So ionic bonding, as I discussed in a little bit about this, the ionic bonding is the electrostatic force of attraction between two oppositely charged ions, ionic bonds with joined metals and non-metals. So these bonds are formed between metals and non-metals. Okay, this kind of bond, which ionic bond is there, it is formed between the metals and non-metals. Suppose here you can see that the sodium has having one extra electron, so it is rich in electron. But for completion of octet, chlorine is less than 1 electron. Here you can say that 1, 2, 3, 4, 5, 6, 7. To complete octet, the chlorine needs 1 electron. So this electron will be transferred to here. So after transferring electrons, sodium will become Na positive. That will be the cation. And chlorine will become chlorine negative, which will become anion. So this thing, after coming to this, it will be Na positive and Cl negative. This bond between this chlorine and negative will be ionic bond because the ions are formed in the term of cation and anion. This transfer of electron leads to formation of ions and which resulted in the form of ionic bond. Next, we are going to cover covalent bonds. Okay. So it is a shared bond. We are going to cover more in distance. First, we'll discuss more about the ionic bonds. Here you can see that sodium, as I discussed in the previous slide, is having one extra electron. Here you can see that. Uh, let's just wait a minute. This extra electron is there, which is transferred to the outermost valency cell of the chlorine. Now chlorine is gaining one negative charge because it grasped one electron from the sodium. And sodium lost one electron, so that's why it is grabbing one positive charge, and they are coming closer and making a bond. This kind of bond is known as ionic bond. Okay. And at the net, there is net charge is 0. Similarly, you can see that sodium and fluoride. Sodium also having similarly one extra electron. Fluorine also the same family of the chlorine. So it is one electron deficient. So the electron is transferred from the sodium to fluorine, and this fluorine is gaining one electron, becoming negative charge, and they are coming together and resulting in the ionic bond. So sodium chloride, we know a table salt. Sodium fluoride is another chemical compound. So next we are going for the covalent bond. Covalent bond is a shared bond. This the electron is shared between the two atoms. So this electron is shared between two atoms. Okay. Let's discuss what was the sharing of electrons. Like both the chlorine are poor. One electron pair because one we know that this is 1, 2, 3, 4, 5, 6, 7. It is not octet. One electron less. Here also 1, 2, 3, 4, 5, 6, 7. So seven electrons are there. So there is no octet. So they will share one electron, so that they can octet will be complete. Here you can see that 1, 2, 3, 4, 5, 6, 7, 8. For this chlorine, octet is complete. Similarly, 1, 2, 3, 4, 5, 6, 7, 8. The electron octet is complete here also. So the electronic pair is shared, and this shared electron pair is known as the covalent bond. So this is a single covalent bond, which I will going to cover in the next slide. Here you can see that this chlorine, as I discussed, there is a single bond. So this is single covalent bond. Here you can see that oxygen, when the this two electron is here, still that single covalent bond is formed, but that is not absent. After the formation of double covalent bond, you can see here. So because here you can see that if I can stop this, I'll tell you how it is forming the. Yeah, you can see now the octet is complete. It is forming double bond. So it is an example of double covalent. But initially you can see that here two electron deficient is there. Two electron come together, so they form single bond. So still one unpaired electron is there, which is not okay. So they are going to form the second covalent bond, which is resulting in the complete octet of both the oxygen, and this form the double covalent bond. Now we will see the nitrogen molecule, which is a triple covalent bond. Here you can see that first bond is formed, is still not octet. Second bond, still not okay. Then third covalent bond. So they are triple covalent bond structure nitrogen. So they form the triple covalent bond, and it is the stable octet. So it is a slide which consists of single covalent bond, double covalent bond, and triple covalent bond. Okay. Now next we are going to study more about the example of ionic compounds. Here you can that this is sodium chloride, which is double table salt, sodium bicarbonate, carbonate, and HCO3, which is very basic example of baking soda, sodium hydroxide, which is a drain cleaner, sodium hypochlorite, it's a bleach. magnesium sulfate, which is the Epsom salt. Here are some of the example of covalent bonding, that sugar crystals. These are sugar covalent compounds. Vinegar, acetic acid. Plastic bottles also consists so many covalent compounds. Then diamond, which is also a covalent bond. Nail paint remover, LPG, air, all contains covalent compounds. So this is all for today. Uh, Let me stop here for today's class.